So let's see what we're gonna do here. Well, I'll find out actually. Now I'm learning. What is this? Nope. Okay, cool. Yeah. It'd be nice if I could get a view of when I'm getting inputs and outputs for sound. But it looks like things are working, so I'll save that for another day. So what am I trying to do here? I have an assignment to work on that involves messing with some files, some image files. I don't know anything about image processing. So this is going to be fun. This is gonna be fun. So essentially what I want to do right now is to get an idea of what kinds of files I'm working with. So, and for that I'm going to use the Python pillow library to extract some metadata out of for the images that I have to work with. So here's what I know. From this directory, there is a problems subdirectory, then there are problem sets listed in here. So let's look at this one. And then under each problem set, there's a directory containing information about each problem. So let's look at this one. Here we see all the pictures that are part of this problem. And really the pictures that I care about are these 1, 2, 3 up to 6 and A to C pictures. Okay, those are the ones that I care about. So let's do it. Go back here and we are going to say from .l import image. Fine, and then we also want to import glob because we are going to do globbing. Thing is, I don't use this library very often, so I'm going to look up some documentation for this module. To see what is possible. I think I may also, I'm not quite sure yet, but I might need pathlib and I might need OS. So let me see what's going on here. So there are what information do I want to get out of this? Essentially, I want to get a set. So I want to get a set that comprises of tuples that represent information about these images. And essentially, the reason why I'm using a set is because I'm looking for uniqueness, right? I want to verify that all the images in these problems, at least from a metadata standpoint, are unique. Cool. So here's what we are going to do. All right. Oh, wow. So this glob library, this glob module doesn't have a lot going for it in terms of API surface. There's just glob.glob, glob.iglob, and glob.escape. Okay. So essentially, using the star pattern in large directory trees may consume an inordinate amount of time. Okay, well, let's try some things and see what we're doing. So what I want to do is for path, let's call this image path in glob.glob, and this is going to just be, here we have problems, then we have problem sets, then we have the problems with the images in there, and then okay, so path name. Yeah, this should work. All right, so here's what we're gonna do. What I want are the 8C and 1 to 6 .png files, and let's just run this. See if we get some I misspelled something. Whoop. There we go. There we go. Okay. So we have everything we want. And the next, I don't think I'm going to need pathlib. I'm not sure about OS. We'll add them as necessary. Cool. So I have my image path, and what I now want to do is to open these. So with image.open with this image path, and I want to save this as image. And then I want to add, so image metadata not add. And what I'm going to add here is a tuple. And this tuple, I want to have the image size, which I know is a tuple of width by height values in terms of pixels. I want to know its mode. And I don't fully understand the information that's in here, but there is an info property on this as well. Image.info. So looking at the pillow library documentation, this says it's a dictionary holding data associated with image. It's used by file handlers to pass various non-image information from the file. Okay, most methods ignore the dictionary. Can return in new images. Unless noted elsewhere, this dictionary does not affect saving files. Okay. What else? Well, We already know that the format is PNG, so there's not much point in getting that out. So I think it's enough for me. What is image metadata not defined? Aha. There we go. And with that, I want to see what's in this set. Okay. So let's do for and this image metadata set, we're going to print this elem, right? And again, these elements should be tuples of image size, image mode, and image info. Now, my expectation is that the size and the mode are all going to be the same. Image info, I'm not quite sure what might be the case. And it very well may be that it's not important for me to rely on differences in the info dict later on in my assignment. So let's just do this. Okay, unhashable type dict. Okay. So any element that goes into a set needs to be hashable. Understandable. So what I'm probably going to do is to just turn this into a string, which is hashable, and do this. Oh, I missed some things there. For example, I do not need this to be printed out anymore. And I'm seeing that I only have one record in my set, which tells me that all the images are 184 by 184. They're RGBA images, right? They have 4 channels. I'm still learning the lingo for image processing, but they have their red, green, blue, and alpha channels. And then this I don't know. Let's do some ducking. Let's duck sRGB and see what that is. And I mean, we get what the RGB is. What does the S stand for? Okay. So what does Wikipedia have for us regarding sRGB? Okay, so sRGB is a standard red, green, blue color space that HP and Microsoft collaboratively developed. Okay, so it actually stands for standard RGB. But what does its value represent? What does its value represent? It is often the default color space for images that contain no color space information, especially images if the image's pixels are stored in 8-bit integers per color channel. It kind of makes sense that this would be stored as 8-bit integers. That much I know, like 0 to 255 fits within the 8-bit integer range. Okay. I'm not really seeing what I want to see here for SRG. Yeah, I'm not picking it up right away. Let me look at the info dict here. So Hill doesn't actually tell us. Pillow doesn't tell us what the range of that sRGB value should be. Okay. Gamma and DPI. I remember learning a little bit about DPI when I was learning about printers a while back. It's something to do with pixel density. Is that right? I don't know. DPI, dots per inch, is a measure of spatial printing, video or image scanner. Measure of spatial printing. Okay. Dot density. Cool. Yeah. Kinda right, I think. Pixel density. Sure. The number of individual dots can be placed within a line of 1 centimeter. Why is it a tuple? Nope, I see 9 to 6. Okay, so Microsoft essentially wrote its software to assume that every screen provides 99 PPI. I mean 96 PPI. Microsoft tried to solve both problems with a hack that has long-term consequences for the understanding of DPI and PPI. I don't know what PPI is. Let me scroll up. Are they essentially the same thing? Oh, pixels per inch. Okay, yeah. So we have a DPI representation, which seemed like it had something to do with printers. And then there's PPI. Okay, here's the section on Wikipedia. In printing, DPI refers to the output resolution of a printer or image center, and PPI refers to the input resolution of a photograph or image. DPI refers to physical dot density of an image when it's reproduced as a real physical entity. Okay. And a digitally stored image has no inherent physical dimensions, yada, yada, yada. And so PPI makes more sense. Subdigital file formats record a DPI value, or more commonly a PPI value, which is to be used when printing an image. Okay, so whatever is going on with all that, which I hope makes more sense as I get used to all this image jargon over the next couple months. Is that where you're using DPI? All right. I don't think this information is going to be relevant for what I'm going to do with these images, as far as I can tell right now. Maybe it'll come in handy later on, but at least I know that the image dimensions and their mode are uniform across all the problem sets. That's nice. Okay, and that's really the only question I had regarding these images for now. I'm sure there's more, but I would like to take some time to just go through the directories and inspect the images manually to see what their contents are like, and then I'll have some different questions that may be more useful to what I want to do. Cool. And that's that.